Okay, can I get everyone's attention back here now? So, if we have a look at this, so you guys have been working these out and getting your answers. Now I've tried to save time by writing this part down. So what we've done is we've got f of x as x plus 2. Our formula to find the derivative is the limit, and this is all by first principles, okay? So the limit as h approaches 0, f of x plus h, take away f of x. So here I put in my f of x plus h into that, plus my 2. So that was that, plus my 2, and then I've got to take away f of x. So there's my f of x, which is x plus 2. So that becomes x plus h plus 2, and I take away all that. They cancel out. I'm left with h over h. What does h over h equal? 1. Okay, so I've still got my limit here. So I've got 1. Now, I've got to sub in h equals 0 into this equation. Is there any h's to sub into? No. So my answer is simply f dash of x equals 1. Okay? There's nothing more I can do here. So, any questions on that? No? Now if I go to this one's a little bit more complicated. I've got x squared plus x. So where I put my f of x plus h, thanks, there's my x squared plus h squared, there's my x plus h, and then I've got to take away my f of x, which is all of that. So I'm taking that away. So when I expand that part out, there's my squared term, there's my x plus h, expand that bracket out there, and I get negative all of this. So I've got a negative x squared and an x squared, so they can cancel out. A negative x and an x, they cancel out. Then I'm left with all of this. What's the next step that we have to do?
Factor out h.
Take out a common factor of h. So I'm left with 2x plus h plus 1. Yep. I've got my h on the end, taking out a h there, h there, h there. That's all over h.
Oh, because it's h times h. H times h.
Okay. So now I'm left with 2x plus h plus 1.
So if I don't expand these brackets,
So my next bit, I sub in h equals 0. There's nothing to sub in there, so I've left with my 2h. That's 0 plus 1. So I'm left with 2x plus 1. So all of this craziness comes down to something very simple. Now if I do this, once again, that's my x, f of x, there's my x cubed, x squared, plus my 1, take away f of x. This part here is my expansion of that. This part here is my expansion of that, plus my 1. Then I've got to take away all of this, my f of x. X cubed, take away x cubed, x squared, take away x squared. So they all cancel out. I'm left with all of this. What have I got to pull out? H. So I'm left with 3x squared. I'm left with 3x h. I'm left with h squared, 2x plus h. Over h. They cancel out. I'm left with 3x squared plus 3xh plus h squared plus 2x plus h. Now I can sub in my h equals 0. And what have I got? I end up with 3x squared
plus 2.
plus 2x. Yes! So
she read that one.
It's really, really,
And I got
it's a really, really satisfying feeling when you can go through all of this and get this. Now, does anyone notice any patterns between this and this, this and this, this and that?
So, is it because like you think of like a square with the answers to x, and you put like a cube with the answers to x?
You're on the money. You're getting there.
We did this in
What's the answer is three.
what was I think of when you had to do that learning?
So, what is the power of this x? 1.
So then you have 1 x again. No x.
So, that 1 comes down to there. We've got 1. But something happens to the x in this one. This 2 goes down to there. What's the power here? 1. This 3 goes down to there. What's the power there? This 2 goes down to there. What's the power there?
1.
You're losing power.
How do we figure it out?
I'm losing a power.
But you're getting a number out the front.
And I'm getting a number out the front.
It'd be good if we had that guarantee was done as well.
There you go.
So, that 1 goes out the front. Where does the x go? I'm losing a power, aren't I?
The power of 0.
It goes to 0. What's anything to the power 0? 1.
Sure, something like that.
So what's 1 times 1? 1.
Oh, what's 0? Okay, 0.
This x.
Is it actually?
This had a power 1. That went to there, became a 1. X, we lost the power, became 0.
So we have
So x to the power 0 is 1. We've got this. This went down to the front. Take away a power, becomes 2. That 2 went down to the front. Take away a power, you get 1. So, all of this long way of doing it, way back, Isaac Newton, he was the brainchild of calculus.
Gravity.
He started doing this. He did do gravity as well. He was doing this. And then he started doing all of this, obviously this long way from first principles, and then realised there was patterns. So if you're told in any test, any exam or anything like that, that you have to find the derivative from first principles, this is what you have to do. If you've just asked to find the derivative, you can follow this pattern. Okay? And then that is what 17b is all about. Is just looking at it and finding the patterns. So we're going to go through and have a quick look